Alright, so we are again busy with Mathematics Higher Level Paper 2 of the August 2020 exam for the Khomas region. Higher Level paper. And we are on question 3 today. Okay, the function f is defined by f of x equals that for all real numbers. Find the range of values of x for which f of x is greater than 1. Okay, straightforward, we just do f of x greater than 1. So we write 2x squared minus 6x plus 5 is greater than 1. Okay, let's take the 1 over. So 2x squared minus 6x plus 4. 5 minus 1 is 4, right? Greater than 0. Okay, so up to this, it's the same as if it was just an equal sign. The next step is still the case. We can divide everything by 2 here. So we can have x squared minus 3x plus 2 greater than 0. That just makes life a little bit easier. So now we can factorize this into x minus 2 and x minus 1 greater than 0. And now this is where it deviates from an equation for the inequality purposes. So now we have to find our critical values. Right. Let me actually show you what happens if we just assume it works the same as an equation from here. So then what some people would do is say either this bracket is greater than 0 or the other bracket is greater than 0. And then they'd get x is greater than 2 or x is greater than 1. And this will be a mistake. Right, so let's backtrack a little bit and see how we actually should do this. So we find our critical values, and that is when we do put each of them equal to 0. So we find x minus 2 equals 0, which means x equals 2, or x equals 1. Now these critical values, they help us on our graph. So that means the x-intercepts are at 1 and 2. Right, 1 and 2. And we see it's a smiley face parabola, right? The a value is positive. Smiley face parabola, and we're asking where is this parabola above the x-axis, greater than 0. So we see it'll be this part of that arm and that part of that arm, right? So everything except for this. So that means all the values to the left of 1 and all the x values to the right of 2. For all of those, the graph will be above the x-axis. So we know that means x must be less than 1 or x must be greater than 2. And that is our answer in this case. So x less than 1 or x greater than 2. Well done. Now find the set of values of p for which the equation f of x equals p has no real roots. Okay, so let's first set the equation equal to p. So that would be 2x squared minus 6x plus 5 equals p. Okay, so let's take the p across. 2x squared minus 6x plus 5 minus p equals 0. So again, we see we have a quadratic. And what do we know about the roots of a quadratic? Well, we know if our discriminant, which comes from, let's do where that comes from. So we know the roots of a quadratic equation has this form. Negative b plus or minus square root of b squared minus 4ac over 2a. Right, that's the first longish formula that I ever memorized back in the middle of high school. So the important thing to notice here is this square root part. So that b squared minus 4ac, we call that our delta, our discriminant. And why is that useful? Well, if this part is 0, then we can simplify the equation to negative b plus square root 0 over 2a or negative b minus square root 0 over 2a. Now what happens here? Square root of 0 is just 0, right? So we've just got negative b over 2a for both cases. So in this case, so if our discriminant, whoa, that looks like an a. If our discriminant equals 0, what do we have then? We have equal roots, or just one root if you want to think about it like that. They're both the same, so this equals that, right? So we have equal roots. On the other hand, if our discriminant is greater than 0, then we've got negative b plus some value and negative b minus some value. So those will be different, they won't be equal, right? So we have two different or distinct roots. Oh, sorry for my handwriting, I know that is horrible. What it says is two distinct roots. And the other option, so we've already got equal to 0, greater than 0, so the other option is less than 0. So what happens then? Well, then we've got negative b plus the square root of a negative number or negative b minus square root of a negative number over 2a. What happens here? This we cannot evaluate. We cannot evaluate the square root of a negative number. So these don't exist. At least they're not real numbers. Let's rather say that. So then we have no real roots. No real roots. And this is what we're looking for here, right? No real roots. So all we want to do is we want to say the discriminant, or the delta, must be less than 0. So that is exactly what we're going to do. So we are going to say, for this, the delta must be less than 0, which means b squared minus 4ac must be less than 0. So b squared minus 4ac must be less than 0. So let's just substitute in our b, a, and c values. So b in this case is the coefficient of x, so that's negative 6. So negative 6 squared minus 4 times a in this case is the 2. And the c in this case is the 5 minus p. 5 minus p less than 0. And now we just solve for p. So negative 6 squared is 36. 4 times 2 is 8. And then 5 minus p less than 0. So 36, negative 8 times 5 is negative 40. Negative 8 times negative p is plus 8p less than 0. So here we got 36 minus 40 is negative 4 plus 8p less than 0. And we're almost done. And we can take the 4 over and just have 8p must be less than 4. And divide by 8, so p must be less than a half. So if p is less than a half, then we will have no real solutions or no real roots for that function. Okay, now function g is defined by this. Okay, so that's the same function, but in this time only from 0 to 4. That's the whole domain. So if we were to draw our graph, it'll only be from 0 to 4. Right, so let's say something like that. Right, if that's at 4, that's at 0. So only for this little part from 0 to 4 is it defined. So we're looking for this part. And they tell us to express that function in this form. Okay, so this 0 to 4 part doesn't matter in question C here, but it will in question D. In question C, how do we get from there to there? Well, we just do completing the square. So let's just rewrite our function, 2x squared minus 6x plus 5. And then we're going to apply the completing the square sort of steps in order to get it in this form. Okay, so in order to do that, we want to make sure that the coefficient of x squared is 1 to start with. So we can factor out that 2. And then what's left is x squared minus 3x plus 5 over 2, right? Took a 2 out of each term. And once we've done that, now we can apply the next steps. So that is rewrite the first 2 terms. And then we want to add and subtract something so we don't change the value. We want to do the same thing, adding and subtracting. And what is that thing that we add and subtract? Well, that's the coefficient of x, so this number here over 2 squared. And we want to subtract it again so we don't change the value of anything. And then we add in our plus 5 over 2 at the end. And now why did we do that? Well, we did that so that this part is now a nice perfect square. Hence the name completing the square. So this becomes a nice little bracket, x, that sign, and then whatever's in the bracket here, which is 3 over 2 in this case, squared, and then we just work out what this is. So 3 over 2 squared is 9 over 4, sorry, there's a negative in front, and 5 over 2, so we can make that a 10 over 4. So negative 9 over 4 plus 10 over 4 is positive 1 over 4. And then finally we just multiply the 2 in. Okay, so 2 times x minus 3 over 2 squared plus, and then a quarter times 2 is a half. Great, so there is our answer. 2x minus 3 over 2 squared plus 1 over 2. And it would be fine if you used decimals as well. So if you had as your answer x minus 1.5 squared plus 0.5, that is perfect, no problem. I just prefer fractions because we work with integers instead of decimals. I don't like decimals. Okay, now find the range of g. Okay, so this is where this picture comes in handy. I'm going to redraw something similar here. So I'm going to say, I'm actually going to draw, let's try and be accurate just to show what is actually happening here. So first of all, I'm going to say, I'm going to claim, and then we'll see why that happens. Because our domain is from 0 to 4, our minimum value is going to be 0, so we have to evaluate g at 0. We have to evaluate g at 4, but we also have to evaluate g at the turning point, the x value of the turning point. All right, to get our range for this specific domain. So let's see why that is. Let's draw the graph. And so here we can read off the turning point here, right? That's 3/2 and a half. So if that's 3/2 and that's a half, so there's a turning point. G of 0, let's evaluate g of 0. So that would be when we substitute x for 0. So 2 times 0 squared minus 6 times 0 plus 5. So that equals 5. So over here somewhere we've got a 5. Let's make it a little bit lower. Let's do that. And I'm just going to draw this graph in something like that. Okay, so that's at 0, that's at 3/2, and then we still want to find the value at 4, right? Somewhere there. Okay, so g of 4, we can say that's 2 times 4 squared minus 6 times 4 plus 5, and that equals 4 squared is 16, times 2 is 32, minus 24 is 8, and 8 plus 5 is 13. Okay, so this point here is 413, and then we have to find this value at 0. So, oh, we already did that. That's at 5, right? So that point is 0, 5, and then we need to find this y value here. We can read that off as a half, right? So that's a half. And just to show that it does work, let's just work it out. 2 times 3/2 squared minus 6 times 3/2 plus 5. So that gives us 3/2 squared is 9/4 times 2 gives us 9/2 minus, and then 6 times 3 is 18 divided by 2 is 9. So minus 9. But what I'm going to do is I'm going to say 9 is the same as 18/2 plus, and 5 I'm going to say is the same as 10/2. So we have a common denominator of 2. So 9 minus 18 is negative 9 plus 10 is 1/2. So we see that is 1/2. Okay, so now we need to find the range. So the range is the smallest number to the biggest number. So obviously this is the smallest y value, as we can see on the graph here, and that'll be the biggest y value. So this will be our range if we're only looking at the graph from 0 to 4. So half is our smallest value for y, and then our largest value for y is 13. So that is our range. Okay, so whenever you've got any function you have to evaluate the range for within a given domain, as in this case from 0 to 4, you want to evaluate your function. You want to evaluate your function at the minimum value of the domain. You want to evaluate it at the maximum value of the domain, and you want to evaluate it at any turning point. So all turning points of the domain. And then you just select your smallest value from out of each of these, and your largest value out of these numbers. That'll be your domain from small to large. Okay, I know I talked a lot there. I hope it makes sense, at least what I'm saying. Then we get given the following. The function h is defined by this, which is again the same thing, but this time from k to 4. State the smallest value of k for which h has an inverse. Okay, now what I'm assuming the mean here is has an inverse, which is also a function, because anything has an inverse, right? Any relation has an inverse, but it's not always a function. So I'm pretty sure the mean here, the inverse must also be a function. So for which value of k will that be true? So for a parabola, again, it's just one mark, so we can just write down the value of k will be 3/2, but let's see how we get there. So that will be because if let's draw a graph again. Let's take a very simple graph. Let's take this one, right? So that's just, let's say y equals x squared. And we take its inverse, so it's a reflection in the line y equals x. That'll look like that. Okay, but you see, this is not a function because it doesn't pass the vertical line test, right? It cuts it twice, or at least twice. So how can we restrict the domain of the original function so that if you then take that inverse, it will be a function? Well, let's do that by doing this. Let's say we restrict k, or the domain, to be only x must be greater or equal to 0. So then we remove everything that's less than or equal to 0, or less than 0, and then it'll be the same here. Remove, then sorry, falling over my words here. So this is the original function then for the domain x greater or equal to 0. Now if we find that inverse, it just looks like that, which now is a function. So that's perfect. So in essence, what we want to do is we just want to restrict the domain to anything from the turning point to the left or to the right. So for this one, we could have also done just that part, and then we'd have just this part, which is also a function. So you can restrict it left or right, doesn't matter. But for our case, we go from k to 4. So our picture here, if we just do this part, just from 3 over 2 to 4, then we can have that reflected in line y equals x, and we have something like that, which is a function. So we just restrict it from the turning point to 4, as they tell us here. Okay, so for a parabola, always just look at the turning point, just cut it off on the left or the right, and then the inverse of that will be a function as well. Okay, now they tell us for this value of k, find an expression for the inverse. Okay, so for this value of k, that doesn't really matter too much. We don't have to think about that really. We just want to find the inverse now, and now the inverse will be a function because we already found the value of k for which that'll be true. The 2x squared minus 6x plus 5, so that is our function h. Now if we want to find the inverse of h, what do we do? Well, we swap the x and the y values around and then make y the subject of the formula again. Okay, but I'm just going to rewrite this in our completed square form because that'll be easier to work with. So actually, yeah, let me erase this. Oh, I chose a small eraser here. And rewrite that in the form we found over here. That'll be this part. 2x minus 3 over 2 squared. So 2x minus 3 over 2 squared plus a half. Okay, so we've got y equals that. Now for the inverse, we want to swap that around. And we want to say x equals 2 times y minus 3 over 2 squared plus a half. And then solve for y, or get y by itself. So the first thing I'll probably do is subtract a half from both sides. So we get x minus a half equals 2 times y minus 3 over 2 squared. Then I'll divide everything by 2 to get x minus a half over 2 equals y minus 3 over 2 squared. And then finally I'll take the square root. Alright, so then the square root would be square root of x minus a half over 2, and that still equals y minus 3 over 2, and then finally I'll plus 3 over 2 on both sides. So the inverse equals the square root of x minus a half over 2 plus 3 over 2. And there we have our inverse. So inverse is just swap x and y around and make y the subject of the formula. Okay, so that's it for question 3, and I'll be back with question 4 shortly. And like always, if you did anything differently, or if you have a different method to solve it, leave a comment in the comments below and let's discuss that. Let's see what is the most efficient way or the most exciting way to solve the question. Because in mathematics, the beautiful thing is there's always like 1,000 different ways we can get to the same answer without doing anything wrong mathematically. Alright, please let me know, and then I'll see you again shortly for question 4.